Okay, we're on the home stretch now. We're almost done. We've got the trapezium rule. Okay, so with the trapezium rule, we're going to have, from our formula book, we get given, let me see if I've got it. Yeah, we get given this formula. So your first step is to identify your h. Now your h is always your difference in your x's. So h is 0.25. And then you want to identify your y naught. That's your first y, your yn, which is your second y, and you are going to stick it right down exactly as it's given in the formula book. So you've got the integral between 2 and 1, your y dx equals 1/2 times h, which is 0.25, okay, big squiggly bracket, y naught, which is 8.32, plus yn, 99.8, plus 2 lots of everything in the middle, 21.4, 40.6, 66.6, close squiggly brackets. And you can type it exactly like that into your calculator. They want it to 2 significant figures. You type that in and you'll get 46. So out of the 3 marks, 1 mark for identifying the h, 1 mark for that big long line, and there's only 1 mark for the actual solution. But you need to write it out. Okay, so there's the first bit, which is our trapezium rule. Part B, we're going to be using a substitution of u equals x squared. So let's rewrite the original equation. So we've got ln 2x squared dx, and we know the limits were between 2 and 1. Okay, so we start off with our u. The first step is du dx to give us 2x, and you're going to rearrange that to make dx the subject. So you've got du over 2x, and we could say, well, we can see here that x is the same as the square root of u, or u to the power of 1/2. So this is the same as du over 2u to the 1/2. Then you're going to do your limits. So you've got your x's and your u's. So x is 2, u is x squared, so that's going to be 4. That's 1 and 1, which agrees with what they have. And now you substitute. So we can do 4 and 1, 12. Instead of x squared, we've got u. ln, instead of 2x squared, we've got 2u. And instead of dx, we've got du over 2u to the 1/2. Okay, so we can see here that 2 is going to cancel and make that a 6. This u to the 1/2 is going to cancel and make this one u to the 1/2. And if I rewrite that, I've got between 4 and 1, 6u to the 1/2 ln 2u du. And so I've shown that we've got the same thing. And now we want to integrate that. Now this time we can use by parts, and we know it's going to work out nicely and it's not that weird formula because we have an ln. So remember, ln always takes priority. So that is going to be your u and that is going to be your v dash. So let's get our by parts formula up again. So we've got our formula for integration by parts, which is at the bottom and is given to you on in your formula book. So we've got u, we're going to let u equal ln 2u. So it always takes priority as u. We don't know how to integrate it directly. And v dash is going to be 6u to the 1/2. Right. So we've got our formula, we know where it is. We're going to use that formula. So we're going to differentiate the u. Now remember, when we differentiate ln, so this is weird because we've got u and u. So if we call this, okay, that's very annoying. I'm going to call this like a big U. So du, d small u. Right, so whenever we differentiate ln, whatever's in the bracket goes on the bottom, the differential of the bracket goes on the top, In this case, because it's 2u, it just becomes 1 over u. And when we integrate, we add 1 to the power. So we're adding 1 to the power. So we've got 6u to the 3 over 2 divided by 3 over 2. And that's going to give us 6 times 2 divided by 3. So it's going to give you 4. 4u to the 3 over 2. Okay, so then we're going to stick our values in. And so that's going to be big U there times V. So we get 4u to the 3 over 2 ln 2u minus the integral of these two multiplied together times 1 over u du. Right? So that's going to cancel out nicely. So we get rid of, so if we do 3 over 2, and we're going to be minusing 1, so that's just going to give us 4u to the half there. So do that. And so the final integration, which we're going to stick values into, is going to be 4u 3 over 2 ln 2u minus, so add 1 to the power to make it 3 over 2, divide by 3 over 2, which is going to leave you with 4 over 9. And we want to stick our values in of 4 and 1. So we'll get sticking 4 in. We're going to have to do it in bits because it wants it exact. So we get 32 ln 8 minus 64 over 3 minus 4 ln 2 minus 8 thirds. Should be 3. And when you clean that out, you're going to end up with, they want it in terms of ln 2. Okay, so let's take this last bit and let's add in some space to do it. I'll just add a sheet and let's put that there. Okay, so we've got to the point where we've got 32 ln 8 minus 64 over 3 minus 4 ln 2 minus 8 over 3. And what we want to do is we want to make sure our answer is in that form. If you notice, we've got an ln 8 here, and they just want everything to be ln 2. So remember, 8 is the same as 2 cubed. So we've got 32 ln 2 cubed, and that 3 can come down. So we end up having 32 times 3, so 96 ln 2. And then we can do minus 64 over 3, minus minus, which makes a plus. So minus 64 plus 8, which gives you minus 56 over 3. And then we've also got minus 4 ln 2. So my final answer is going to be 92 ln 2 minus 56 over 3. So A equals 56 over 3. Minus 56 over 3. And B equals 92. So just always make it super